Now dear student, we are going to discuss question number 7.32, and in this question it is given to you, read each statement and with reason tell me this is true or false. Clear? Now concentrate on a screen. In this question it is given part number A, during rolling the force of friction act in a same direction as the direction of motion of a center of mass of a body. Perfectly true. Clear? It is given during rolling. Clear? So I can say this statement is true. Clear? Because actually what is the work of this friction? Actually the purpose of a friction is to bring that body in a pure rolling condition. As the pure rolling condition is achieved, the friction force automatically becomes zero. It means we can say this statement is true. Clear? Now if I talk about statement number B. In statement number B it is given, the instantaneous speed of the point of contact during rolling is zero. Yes, definitely. Let's suppose if I am talking about, let's suppose here we have a body. Let's suppose this is any body, it may be ring and something else. Let's suppose if I am talking about this point of contact. So if I am saying in a pure rolling condition, the tangential velocity, let's suppose this is going in this direction omega. So I can say this V equal to R omega. This should be balanced here. Clear? And how it will be balanced? Because let's suppose center of mass velocity, it increases up to R omega. Clear? So at that time we can say this V equal to R omega and this V equal to R omega. Clear? We can say at point of contact this V equal to R omega becomes. Clear? So actually what I want to say, I just want to say, whenever we are discussing about pure rolling condition, in pure rolling condition at point P, this velocity V, this should be equal to R omega. This is a condition of a pure rolling. Clear to you? Yes. Now it means we can say this statement is true or false. This is true. Clear? Now if I am talking about part number C, the instantaneous acceleration of a point of contact during rolling is zero. This statement is false. Why this statement is false? Let us try to understand. Yes. So I can say this statement is true, this statement true, and this one is false. Now listen carefully what I am saying to you. Let's suppose here we have this surface and let's suppose we have this body. Clear? And let's suppose this body is in a pure rolling condition. Clear? So in a pure rolling condition we can say this body does not have any translatory motion. Clear? Translatory motion this body does not have, but actually this body is rotating. Clear? Or actually this body is rolling. Clear? So in a pure rolling condition we can see acceleration will always act at a point of contact that is towards center along radius, that is known as centripetal acceleration. So always keep in mind we can say in a pure rolling condition at a point of contact you will always find velocity V equal to R omega, or net velocity at the point of contact, that is zero. Yes or no? But what about acceleration? Acceleration, it may or may not be zero, but because we can say here this is a rolling, so whenever we have a circular motion, centripetal acceleration come into picture. Clear? So we can say this statement is false. Okay. For perfect rolling motion, work done against friction is zero. Definitely true. Why? Because if we are talking about pure rolling condition, in pure rolling condition we can say value of friction is zero. Clear? So value of friction is zero, it means this is true. Clear? Last one. A wheel moving down a perfectly frictionless inclined plane undergoes slipping, not motion. This is also correct. Why? Because rolling is possible only due to friction. When friction is absent, definitely we can say that body just skid. You can see, let's suppose we have a rough surface, I have a ball, at the time the ball will move like this. Clear? But let's suppose I have frictionless surface, at the time that ball will move directly like this. It only skid. Clear? So directly we can say this statement is also true. Clear? So this is all about this question.